Dear children, in the applications of differentiation, one topic 7.9 section, symmetry and asymptotes. Symmetry and asymptotes. What is the meaning of symmetry or symmetric? Anyone? Symmetric or symmetry? Anyone? Symmetry meaning if an image or a curve is mirror reflection of another image with respect to a line, we say that image or the curve is symmetric with respect to the line. It is defined as any curve we consider that curve image with respect to a line. That line is called a symmetric line. Suppose here one curve is here. This curve or image of this with respect to a one line in outside, opposite side, one curve is there. So this image reflection of another image with respect to this line. This is the symmetric line. This is the symmetry. So this curve is called symmetry of curve. Symmetry of curve. So here this line is called symmetric line. Like that. Here mainly three symmetric are there. One is horizontal axis and another is vertical axis, otherwise x-axis or y-axis, otherwise origin also. Three topics here. One is one means here A taken as, one is symmetric about x-axis. One is symmetric about x-axis. Another two, symmetric about y-axis. This is the second topic. And the third topic is the symmetric about origin also. Symmetric about origin. These are three types. First one is what? Symmetric about x-axis. Second one symmetric about y-axis. Third one symmetric about origin. Three types. So in these three types, how we define the symmetric about x-axis, how we define the symmetric about y-axis, how we define the symmetric about origin. So here one condition having number in the A symmetric about x-axis, how we define? Suppose f of x comma y is a real valued function. Real valued function. The function in terms of x and y. It is the real valued function. Then if we substitute instead of y, substitute minus y. Then the function does not changed. That means f of x comma minus y is equal to f of xy. Same function will come. F of xy, same function will come. When instead of y substitute minus y, then it is equal to f of xy. Then this curve symmetric about x-axis. Symmetric about x-axis. F of x comma minus y is equal to f of xy. Then this is called symmetric about x-axis. And second B. Second B. This is also similar to that. F of x comma y is real valued function. Real valued function. Instead of x, substitute minus x. Instead of x, what we substitute? Minus x. Then the function does not change. F of minus x comma y is equal to f of x comma y. same function will appear here. Then it is symmetric about y-axis. This is called symmetric about y-axis. When if instead of x substitute minus x, the function does not change, then this function is called symmetric about y-axis. Okay. Similarly, and the third point, C, f of xy is also real valued function. This is also real valued function. Here, instead of x minus x substitute, instead of y minus y substitute, then this function does not change it. That means f of minus x minus y is equal to f of x comma y. So same function will appear when if you extend x instead of x minus x, instead of y minus y, substitution, after substitution that function does not change. Then this function symmetric about origin, symmetric about origin. So for these three topics, that curves, how is like that, we discuss about the graphs, symmetric about x-axis. For example, best example for this, x is equal to y square. X is equal to y square. In another way, y square is equal to x also. Same function. X is equal to y square, otherwise y square is equal to x. So here x power 1, y power 2. So here we substitute y is equal to minus y plus y square. Same function, x is equal to y square coming. So y does not change here. This function does not change. So what is the x power 1? This is, if x power 1, where is the 1? That is the x-axis, symmetric about x-axis, not y. So this is the parabola. Actually y square is equal to 4ax, type this one, y square is equal to 4ax. This curve we know. This is the standard curve of a parabola. Here 4a is the 1, that means 1x. So y square is equal to 4ax or y square is equal to x. It is the right open curve. X-axis, y-axis are same. This is the y square is equal to x. Otherwise x is equal to y square. So for this parabola, for this curve, x-axis is the symmetric. This is the symmetric. Symmetric about x-axis. For this curve, y square is equal to x. So symmetric, suppose consider any point here p of x comma y. Here in opposite side, with respect to this x-axis, this point is p dash x comma minus y. In the first quadrant plus x plus y, in the fourth quadrant plus x minus y. So here plus y, here minus y. But same distance, this also y distance, this also y distance. But this is the upside, that's why it is the plus y, this is the downside, that's why it is the minus. So this plus y, this minus y, substitute in this plus or minus y whole square plus y square is equal to x. So here y square does not change. So here x, y square is equal to x power 1. So this is the symmetric about x-axis. This is over. Symmetric about x-axis is over. For the example is x is equal to y square. After this, second, symmetric about y-axis. Symmetric about y-axis. So how? What equation satisfied this? Y is equal to x square. Consider this equation. Here instead of x put plus x minus x. there is no change in the function. That's why y is the symmetric axis. So here what is the topic? Symmetric about y-axis. So this equation again we written as x square is equal to y. So this is the type of x square is equal to 4ay. Here 4a is equal to 1. So x square is equal to 4ay up open curve. That's why this is the x-axis, this is the y-axis, it is the origin. Okay. This is the standard curve. Up open. This is the x square is equal to y, otherwise y is equal to x square. So suppose consider any point here f of p of x comma y. We draw the line to opposite with respect to y-axis. Here another point p of minus x comma y. Instead of x, we substitute plus or minus x. Does not change the equation. Plus minus whole square is the positive. Y is equal to x square as it is. There is no effect on the equation. That's why this y-axis is the symmetric line. That's why this car symmetric about y-axis. Okay. This distance is the x. This distance also x. This is the positive side. This is the negative side. These 2 point satisfy the same equation. That's why y is the symmetric about the y-axis for the y is equal to x square curve. And the third one, symmetric about origin. Third, symmetric about origin. Symmetric about origin. So for this, best example, y is equal to x, otherwise x is equal to y also. X coordinate, y coordinates both are equal. This is the line. Y is equal to x means y is equal to mx. So m is the slope, some value having here. This value here 1, sometimes 2, 3, that type of also having. But we consider y is equal to x. In this substitute, y is instead of y minus y, instead of x minus x. So y is equal to x. So this equation does not change. So that's why what is the principle actually? F of minus x minus y, then it is equal to f of xy. So this condition is satisfied that curve is symmetric about the origin. Draw the curve. This is the x-axis, this is the y-axis. So this is the x coordinate, y coordinate equal. Slope is 1. That means slope 1 means 45 degrees. Slope 1 means tan theta is equal to m is equal to 1 means theta is equal to 5 by 4. So theta is equal to 5 by 4 means half of this x-axis y-axis angle. This is the 45 degrees. This is the y is equal to x line. Otherwise x is equal to y line. Here consider any point p of x comma y in the opposite side with respect to origin. Another point p dash minus x minus y. So this point lies on the same line. So this line symmetric about origin. Symmetric about origin. This is origin. Symmetric about origin. Here the topic is asymptotes. Definition: and asymptotes, it is asymptotes, not asymptotes. Here P silence, here N coming, asymptotes. For the curve y is equal to f of x, that is the function y in terms of x, y is equal to f of x, is a straight line. And asymptotes for the curve f of x is a straight line. which is a tangent at infinity to the curve is called asymptotes. Asymptote is nothing but a line. That line touches the curve at infinity point, not to define the point, at infinity point. That is called asymptotes. Now, in the asymptotes also, three types of asymptotes having. One is asymptotes parallel to x-axis and horizontal, otherwise asymptotes with respect to x-axis, asymptotes with respect to y-axis, asymptotes with respect to slant. Three types having: horizontal asymptotes, vertical asymptotes, and slant asymptotes. In this first one, horizontal asymptotes. And the second one, vertical asymptotes. And the third one is slant asymptotes. Here three types: horizontal asymptotes, vertical asymptotes, slant asymptotes. Here first one, horizontal asymptotes. So how we decide the horizontal asymptotes and vertical asymptotes and slant asymptotes? Suppose here x, this is the y. If x is the a value, then y tends to infinity. If x reach to a, then y reach to infinity. Either a plus or a minus. Here plus infinity or minus infinity will come. Then x is equal to a is the vertical asymptote. Here x is equal to a means vertical asymptotes. If y is equal to a, then x reach to infinity. Where is the infinity? Y is equal to a, otherwise y tends to a, then x reach to infinity. Then y is equal to a is the horizontal asymptotes. Okay. If x tends to a, then y reach to infinity. That means function f of x, limit x tends to a, then this is tends to infinity. So f of x is treated as y tends to infinity. Y is the here f of x. Limit x tends to a, f of x reach to infinity. Then x is equal to a is the vertical asymptote. Here limit x tends to infinity, then f of x is tends to a. F of x tends to a, otherwise y tends to a. This is y. Where is the infinity? X is infinity, then this y value tends to a. Then y is equal to a is the horizontal asymptotes. So how it is this? Here y is equal to a means This is the y is equal to a. Y is equal to constant. This is y-axis, this is x-axis. So how is this? Y is equal to a, this distance is a. This is horizontal to x-axis. This is suppose asymptote. This asymptote parallel to x-axis. That's why it is the horizontal asymptotes. In the similar manner, origin y-axis, x-axis, x is equal to a. X is equal to a means here x is equal to 0. This is x is equal to a. This is x is equal to 0. This x-axis equation y is equal to 0. Y is equal to 0 is nothing but x-axis. X is equal to 0 is nothing but y-axis. So this line is the vertical line. This is parallel to y-axis. That's why this is the vertical asymptote. The curves. So this is the vertical, this is the horizontal. So this equation vertical means x is equal to constants, horizontal means y is equal to constant. That is the difference. Parallel to x-axis, that is the equation y is equal to a constant. Parallel to y-axis, then x is equal to a constant. That is the equation. Next, slant asymptotes. Third point, slant asymptotes. Slant means some slope having line. Y is equal to mx plus c. That is the slant line. Here asymptote is also one of the line. That is also one of the tangent. It is how we define slant asymptotes. Suppose f of x is a polynomial. Fx is a polynomial function. So this polynomial function, in a rational function, f of x is taken as g of x by h of x, suppose. So above gx is also polynomial, h of x also polynomial. Now g of x polynomial degree and h of x degree more than h of x. Here g of x degree of g of x is greater than degree of h of x. In this case, degree of g of x greater than degree of h of x. In this case, the slant asymptotes occurred. In this case only. If it is less than, that asymptotes not exist, not coming. Only in case of degree of g of x greater than degree of h of x, then slant asymptotes exist. Slant meaning with respect to x-axis and y-axis, this is the horizontal asymptotes. This is the vertical asymptotes. So what is the slant asymptote means like this. This type is y is equal to mx plus c type. So m is the slope having. M is the tan theta. Theta is the inclination of the line. This is theta, making some angle with respect to x-axis. This is positive x-axis. This theta is called inclination of the line. Tan theta is the slope. It is denoted by m. Some slope having. Example, y is equal to x plus 1, x minus 11, 2x plus 3. This type of equations. Any x plus y plus constant is equal to 0. Otherwise, ax plus by plus c is equal to 0 type. Any equation, general equation, it is also possible to write y is equal to mx plus c form. So m is the slope. That's why it is the slant asymptotes. Now, example 7.66, page number 49. Question on the asymptotes. how to find the asymptotes? Asymptote means horizontal and vertical and slant. So how many asymptotes here? So maximum 2 asymptotes appear here because f of x is equal to 1 by x, that means y is equal to 1 by x, otherwise xy is equal to 1. Xy is equal to y, xy is equal to 1, nothing but it is the rectangular hyperbola. So any hyperbola having 2 asymptotes. That's why solution here, y is equal to f of x, y in terms of x, both are same. What is the f of x? 1 by x. This is the 1 by x. Now we check the infinity. Where is the infinity function? If x is the 0, 1 by 0, infinity. If x tends to 0, 1 by 0, infinity. Y tends to infinity. If x tends to 0, then y tends to infinity. Okay. That's why 0 plus what? 0 minus what? After that x tends to infinity, then y tends to 0. Then plus infinity check, minus infinity check, left side and right side, both limits. Then here y is equal to 0, here x is equal to 0. Here x is equal to 0 is the asymptote. X is equal to 0, nothing but y-axis. Here y is equal to 0. This means y is equal to 0 means this is the asymptote. Y is equal to 0 is nothing but x-axis. Okay, this is some roughly explanation. After this, now limit x tends to 0 to the f of x, and we check the left limit, 0 minus, below 0 values, what coming? 1 by 0 minus, negative values. So 1 by x, limit x tends to 0 minus. 0 minus means here negative values, something by negative values it is coming to minus infinity. At the same time, limit x tends to 0 plus f of x. This is equal to 1 by x, limit x tends to 0 positive. So these are positive values, 1 by positive values up to 0. 1 by 0, it is infinity. Plus infinity coming. This is minus infinity, this is plus infinity. After that, here x is equal to 0 is the asymptote. X is equal to 0 is nothing but x is equal to 0 is a y-axis. This is the vertical asymptote. Y-axis means vertical line. So y-axis equation, x is equal to 0. So vertical asymptote at x is equal to 0. This is the vertical asymptote. After that, similarly, we check this up to, instead of 0 minus 0 plus, so we substitute infinity. If x tends to minus infinity, then what will come? Limit x tends to infinity minus, x tends to infinity minus. This is coming to 0. Here limit x tends to infinity plus. This is also coming 0. Here x tends to infinity, either plus or minus, both are 0, 0 coming. So here f of x is nothing but y. If x tends to infinity, y is equal to 0 coming. It is nothing but y is equal to 0. It is also nothing but y is equal to 0. So here y is equal to 0 is nothing but x-axis. For this, y is equal to 0 is a x-axis. It is the horizontal asymptote. horizontal asymptotes. X is equal to 0 is a vertical asymptotes, y is equal to 0 is a horizontal asymptotes. So this is the description about asymptotes for f of x is equal to 1 by x. So how is this curve? This is the y-axis, origin x-axis. So if x is equal to 1 put, f of x is equal to 1 coming. If x is equal to minus 1 give, y is also minus 1 coming. So here plus 1, here plus 1, here minus 1, here 1, minus 1. Take x is equal to 1, y is also 1 coming. This is 1 point. Here minus 1, it is also minus 1 point. Now, if x value reach to infinity, if x value reach to infinity, this curve decreasing. X value near to 0 is going to infinity, like this. If x decreases, that function, if x is increases, the function decreases. If x decreases, the function increases up to infinity, up to plus infinity. This also plus infinity. Next, if at minus 1, this point, if x going to this side, right side, this function is coming to this downwards, minus infinity. It is also, if x is a decrease like this direction, minus infinity side, this also going to minus infinity. So this combined equation is the xy is equal to 1. Otherwise, y is equal to 1 by x is equal to 1 by. Both are, all are equal. So xy is equal to constant, any xy is equal to constant represent a rectangular hyperbola. Rectangular hyperbola. For this, y is equal to 1 by x, this is the diagram. Y is equal to 1 by x. Xy is equal to 1, y is equal to 1 by x, is equal to 1 by y. Any curve, for this, these are the curves, 2 branches. Rectangular hyperbola having 2 branches. One is in the third quadrant, another is first quadrant. Combinedly, it is the rectangular hyperbola. This is the origin. So this is the horizontal asymptote. Horizontal asymptotes. This is the vertical asymptotes. Okay. Example 7.67. The question: find the slant oblique. Slant oblique same meaning asymptote for the function f of x is equal to x square minus 6x plus 7 by x plus 5. Slant, otherwise oblique. Slant asymptote. Asymptote is nothing but a one line. Slant asymptote. One line with have some inclination. Slant means that line having some inclination with some angle theta, slope having. So slant asymptote in the form of y is equal to mx plus c. Okay, y is equal to mx plus c. That is the slant line, slope line. Slant nothing but one type of slope. So how we find the slant asymptote? That is the first thing. So there is a slant asymptote, either or not. We discuss about that. If slant asymptote is there in the polynomial equation, the degree of the numerator compare with the denominator more having. So here this function f of x is the polynomial. This polynomial in this equation f of x, x square minus 6x plus 7 by x plus 5 is the function, given function. So here degree of the numerator is 2. Degree of the numerator 2. Degree of the denominator how much? Here x power 1. So this is greater than from this. So degree of the numerator is greater than degree of the denominator. That's why slant asymptote exists. So we write here degree of the numerator, NR means numerator, it is the 2, is greater than degree of the denominator, otherwise dr means denominator, it is 1. So degree of the numerator is greater than degree of the denominator. That's why slant asymptote, there is some slant asymptotes exist. There is one slant asymptote exists. So how we find the slant asymptote? First, we divide the numerator by the denominator. X plus 5, here x square minus 6x plus 7. From long division, here suitable term is what? Here x square first term, here x. So for the suitable x into x, x square. So multiply with the x square. So multiply with the x. After that, x into x, x square plus 5 into x plus 5x. After this, minus is cancelled. Minus 6x minus 5x minus 11x, remaining plus 7 is there. After this, here minus 11x. So here x. Multiply with the suitable term minus 11x. So that's why we multiply with minus 11, minus 11x, minus 11 into 5, 55. So here change the symbols, plus. This 11x cancelled, 55 plus 7, 62. This is the remainder. This value quotient. This is divisor. So this function, how we write? Quotient plus remainder by divisor. So what is the quotient? X minus 11. So this means f of x is equal to quotient what? X minus 11 plus remainder 62 by divisor x plus 5. So here slant asymptote is taken as up to here only, not this. So this is the slant asymptote. F of x is nothing but y. So taken as this is y, otherwise f of x is also no problem. Y is equal to x minus 7 is the slant asymptote. Y is equal to x minus 7 is the slant asymptote. So roughly we draw the asymptotes and a graph. Simply we draw the graph roughly, not accurately. So y is equal to x minus 11 is the slant asymptote. So in this line how it is? So take the table x, y, put the x is equal to 0, then y is what? X is equal to 0 means y is equal to minus 11. If y is equal to 0, x is equal to 11 coming. Okay, we take the graph roughly. This is the x-axis positive, this is the x-axis negative. This is the origin. This is the positive y-axis. This is the negative y-axis y dash. We take the units number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, minus 11, plus 11 this one. And left side also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, minus 11. In this side also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is minus 11. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 plus 11. So here 2 points in the coordinates 0, 11, 1 point, and minus 11, 0, another point. So 0, 11 where? This is the 11. X is equal to 0, y value minus 11, x is equal to 11, y is equal to 0. 0 minus 11. So points 0, minus 11. And here another point x 11, 0. This is the coordinates. Now 11, 0 here. This is the point. Y coordinate 0 means lies on the x-axis. This is the 11, 0 point. And another point 0, minus 11. So x coordinate 0 means it is lies on the y-axis. This point is 0, minus 11. So for the straight line, 2 points enough. For these 2 points, we draw the graph. That line passes these 2 points like this. This is the slant asymptote. Okay. After this, about the graph, this function, how is the graph about this roughly? So this graph, suppose x is equal to minus 5 put in this, here plus 5, x is equal to minus 5. It is coming to function by, it is 0, infinity coming. At x is equal to minus 5, total value is infinity. So x is equal to minus 5, so choose the one point. 1, 2, 3, 4, 5. This is the minus 5. So this is the x is equal to minus 5 line. This is also what vertical asymptote. X is equal to minus 5. It is also vertical asymptote. How? So consider limit x tends to minus 5 plus f of x. We apply the limit x tends to minus 5 plus. Minus 5 plus means after minus 5, this side, right side. So that means minus 5 plus means in this side. So that value minus 4.9. Approximately minus 4.9, minus 4.5, like that. That means what here, what coming? This function x tends to minus 5 plus means minus 4.9. Suppose consider minus 4.9 means 5 minus, here positive coming. So positive infinity. After that, limit x tends to minus 5 minus f of x, what coming? So minus 5 minus left side, minus 5, this point is minus 5. Minus 5 left side, suppose it is the how much? Minus 0.5 left to minus 5.1 or minus 5.2. You substitute here, minus 5.2 means 5 minus minus. So negative coming. So it is negative infinity. That's why here at the minus 5 it is infinity coming. What we say, what is the meaning of asymptote? If x tends to a, then y tends to infinity, then x is equal to a is the vertical asymptote. Vertical asymptote. Already I told you this previous class, x is equal to a vertical asymptote. So here a value how much? Minus 5. That's why x is equal to minus 5 is a vertical asymptote. So how is the graph? How is the graph? It is the big size. Yet x is equal to 0. How much this value? This is the 0. At x is equal to 0. 0 what? 0, 0, 7 by 5 coming. 7 by 5 value how much? 5 ones, 5 fours, 1.4. At x is equal to 0, 1.4. Here, something here value. This is the 7 by 5. So that curve intersected at y-axis at 7 by 5. So that curve here to this slant asymptote, this is also one vertical asymptote. So from this to in this side and in this side, this is the function. This is the function f of x. So one side and another side also, in this side, this slide slightly in this type. So this is the big graph. That's why here not visible to draw here. Here this is the curve and this is also another branch. Anyhow, this is a roughly diagram about this problem f of x is equal to x square minus 6x plus 7 by x plus 5. For this slant asymptote is this one, that is y is equal to x minus 11. This is the one slant asymptote. X is equal to minus 5 is the vertical asymptote. This is the x is equal to minus 5 is the vertical asymptote. Okay.